Welcome to Building No-Code Autonomous End-to-End Tests presented by Applitools. My name is Heather Versillo, and I'm a Product Marketing Manager at Applitools, and I will be your session host today. I'm also joined by our CTO, Adam Carmi. Adam is the inventor of visual testing and the co-founder of Applitools. As CTO, he brings more than 20 years of technological leadership and innovation experience to Applitools. But before founding Applitools, he held management, research, and development positions at SafeEnd, IBM, Microsoft, and Intel Corporation. And Adam regularly gives software testing talks at conferences around the world.
Thank you, Heather. And hi, everyone, and welcome to this session on building no-code autonomous end-to-end tests. So earlier this month, we released a new version of our autonomous testing platform. And it's a great opportunity to share with you some of the new features and capabilities, but also to demonstrate just how easy it is for teams of any skill level to scale your automated test using this platform. Now, this session is going to be entirely a live demo. So except for a few introductory slides, we're going to spend most of the time just seeing the product in action. And of course, there'll be time in the end to answer any questions that you may have. You know, in recent years, there's been an exponential growth in the complexity and scale of software. Enterprises are building more and more applications. These applications are becoming bigger and bigger. The user experience of these applications is becoming more complex and dynamic and more difficult to test than ever before. And on the other hand, teams are expected to increase velocity, release features to production faster, and do all of that with limited resources and budgets. What we see in the field, what we hear from customers, and what we can also see from independent market research is that the traditional approach to test automation simply does not scale. Software testing and test automation particularly is noted as a primary reason for teams' productivity and velocity loss, and it's also highlighted as a primary factor in the overall increased cost of software projects. Now, the goal of autonomous testing, at least as we define it at Applitools, is not to get us all out of a job as quality practitioners, but actually to make automation at scale accessible effortlessly to all. And in order to do that, the tool or the platform needs to be able to attain near complete test coverage, taking teams from below 20% automated coverage, where most teams are at today, to 80% or more. The tool needs to be able to find and catch unexpected defects and not just expected ones. The tool needs to lower the required skill sets from its users in order to succeed at scale, from basically having to be a developer today to succeed with automation at large scale, to being a quality engineer, that is to know how to test. And the tool should also drastically reduce the amount of human involvement in test creation and maintenance from the total involvement that is required today to just requiring humans to view test findings and to fill the gaps where the AI cannot manage by itself. So a quick recap on Autonomous, for those of you who have never seen it before. Autonomous is an automation platform for website and web applications, although at the end of the year, we do plan to release support for autonomously testing native mobile applications as well. It is today the most advanced test development environment in the industry. It provides you everything that you need to test at scale out of the box, from devices and browsers to test your application on, and up to infrastructure for scheduling tests. Everything is 100% SaaS. You don't need to install anything. If you're testing a website or a multi-page web application or a content management system type of application, Autonomous can create an entirely self-maintaining test suite for your application. All you need to do is just give it the URL of your website and it will do everything for you. All you need to do is sit back and look at test findings. For any other type of application, it allows you the ability to author custom flows, in plain English, either write them down or record them with an interactive browser. And you can test that way just about any type of application, no matter the complexity. And you don't need any coding skill or even element locating skill to succeed with that. Everything you do with Autonomous is assisted by a large language model that automatically corrects your mistakes, syntax and grammar mistakes, simplifies your tests, and basically helping you become more productive. You can use Autonomous to test your application across different devices and browsers. You can do visual testing powered by Visual AI, which is by far the most advanced computer vision technology available in the industry today. And you can perform traditional functional and data-driven testing, basically do whatever a developer could do in his coded test, from defining variables, parameterizing tests, placing textual assertions, performing reuse test steps across your test suite, etc. And Autonomous also allows you to do API testing and basically initiate HTTP requests directly from your end-to-end test to get complete coverage both through the front end and the back end. So an extremely comprehensive platform that you will now see in action. And as promised, this was the last slide. From now on, it's only a demo and seeing the product in action. So the first thing we'll do is we'll look at our demo application that we will be testing. It is an e-commerce application that has a bunch of products with product categories. Each product has some details like an image and a description and a price, and you can add them to the cart, and you can check out the cart and go through billing flows. And you can also post a contact us request and submit it. If you try to submit it without providing the necessary details, you get error messages, error labels that indicate that that this data is required. So these are the flows that we will look at in this demonstration. And now we'll start talking about Autonomous and see how we can produce end-to-end tests with it. So as an Autonomous user, I can test as many applications as I want or need. And for each application, we will have specific tests, the test data that drives them, the test plans that allows grouping them together and executing them together, the browsers and devices that we'll use to test the application, and of course, the test results. Right now, I have created a new application called My Application. It appears at the top of the dashboard. You can easily switch to other application and manage your application, renaming them, adding new ones, removing ones that are not needed anymore, etc. So far, we don't have any tests, so let's start by creating our first Autonomous tests. Autonomous supports 3 types of tests. The first one is the custom flow test that, as I mentioned before, allows you to just describe a test case in plain English. You can test an application of any complexity. It could be a business application with specific business flows and data, or a packaged application like a Salesforce application. Anything that has a UI, a web-based UI, you can test using this technique. The other 2 are full website test and URL list test. We will get to them at the end of the demo. We'll now start by focusing on custom flow tests and create our first custom flow test. So in the custom flow authoring page, we have the test details at the top. We can provide a name to our test, and we need to provide the start URL, the starting point of the test. For that purpose, let's use the URL of this contact us form. We can just paste it over here. And now we can also choose the form factor that we will use for testing. This is useful if your application is responsive and you want to write a test that interacts with your application in a specific form factor. We provide 3 form factors out of the box: desktop, tablet, and mobile, but you can also define your custom form factors, the width and height of the viewport, and also the operating system and browser. For the purpose of this demo, we'll just stick to the desktop one. This is what we need. On the left-hand side, we have a room where we can just write down the test steps in plain English. And on the right-hand side, there is room for an interactive browser that will basically play back and show us live everything that we type or replay on the test will show in this interactive browser. So let's run our test. It already has a first step, which navigates to the start URL. The interactive browser is now spinning up, and as soon as it spins up, it will navigate to the start URL. And you can see that we have now the contact us form appearing. Note that the interactive browser is embedded in the dashboard. You don't need to install anything, no local recorder. It has a lot of advantages that we will talk about shortly. Let me zoom in a bit so it will be easier to see what's going on. Okay. We can just start authoring our test in plain English. There is no special syntax that we need to stick to. So for example, we can start by clicking the submit button. As we do that, our language model interprets the English command and executes it. And as you can see, the submit button was clicked in the interactive browser, and you can see that all the error messages indicating the missing fields are showing. We can also look at the step details and see the outcome of the interaction, the button that was clicked, and also we can see the state of the UI before the action occurred. So you can be sure that what you intended to do in the test actually is happening. We can proceed, and I can type my name, type Adam Carmi as name, and the language model will execute that. But I don't really have to write down by hand each and every step of the test. I can actually just interact with my application through the interactive browser, and the test steps will be written in plain English. So I can enter my email, and I can choose a contact reason, and I can submit the form. Okay, and that's it. I've just completed automating my first flow of submitting a contact request. And you can see that all the steps that I actually either wrote down or recorded appear here on the left-hand side. Now that the steps are here, I can easily replay the test and see that everything works as expected on the interactive browser. I can set breakpoints and replay the test so it would stop at a certain breakpoint. I can run the tests step by step, run the step by step out of order. Basically, I can do anything that a developer can do with his IDE when he's writing code. I can do it here only with plain English instructions. This combination of having tests written in plain English and having the interactive browser is extremely powerful and overcomes some of the downsides of traditional record and playback tools. First of all, having the test described step by step in plain English is the most natural, compact, and easy way to understand what the test is doing and maintain it. Second, in terms of the skill set, I only need to know what it is, how to test. I don't need to be a developer. I don't need any developer skills or the ability to write code in order to automate the flows that I want to cover. If you look at the test steps, you can see that they are described in terms of how the user sees the UI, and there are no element locators mentioned here. This is an advantage because as a user, I don't need to understand element locators in order to understand what the test is doing. I don't need to be able to choose good locators. But more than that, the test becomes much more stable because it no longer depends on how the UI is implemented under the hood. So if a front-end developer comes in and refactors some of the UI code or changes it, it is less likely to break my test and require my involvement in fixing it. Another very important advantage is that this combination allows less technical users to overcome recorder mistakes. So one of the big problems with the traditional record playback tools is that if the user records a flow and the recorder fails to record it correctly, and that can happen because developers can be very creative in the way that they implement the front end, then basically the user is stuck because he's trying to record an action and it doesn't work. He has to file a report, open a bug to the vendor that will either provide a workaround or fix a bug in the product. The way that it is different with autonomous is that you can see in plain English exactly what the recorder understood. And if the recorder made a mistake, you can actually edit each of these commands in plain English and help the language model or the AI in that matter understand better what it is you intended to say. So let's say they click the submit button didn't work, you can say at the bottom of the page, or to the right of another element, or below it, or in the header or footer, or anything that you can explain in a better way in the English language that would help the AI engine actually be able to run what you intended to happen properly. Another important advantage of autonomous that is unique to it is the fact that it is 100% SaaS. You don't need to install or download a local recorder, and that solves a range of problems that all other tools have. For example, you don't need to install and update whenever there is a new release. You don't need to deal with installation problems that can occur. You don't need to worry about situations where you have an older version or different than your friends or in the ones that running in the CI, which causes differences in execution and very frustrating bugs. But in general, you can be sure that anything that you record and you play back and that it's working for you interactively will 100% work the same way when the test is running non-interactively or in the CI. And it will work for your other team members exactly the same. And there are many reasons why, if you're recording locally, it won't happen. Maybe you have different network conditions. Maybe you have some local state that is only applies to you when you're performing the recording. Maybe you're already logged in, or you made some choices within the application that affect the recording, and then when the test is running on a different machine, on a different container in the CI, etc., it starts fresh and the test that you composed doesn't work there. So all this range of issues and challenges goes away and doesn't exist. And for many of us that work for strict organizations, let's put it this way, you don't need to ask for permission from IT or security to install updates. Everything is available in the dashboard. Another thing that is great and unique about autonomous is that everything that you do is assisted by a large language model. So for example, if instead of saying click the submit button at the bottom of the page, I say click the submit button at the bottom of the page, and you can see that instead of showing me an error message, the AI automatically corrected it to click, and it actually also shows me that it performed this change, so I'm not surprised. If I'm not a native English speaker and I tend to write test steps that are a bit obscured, let's say at the bottom of the page, the submit button you should click, the LLM will automatically correct it to a normalized sentence that starts with the verb and keep my test clean and tidy for the rest of my team members. Even if I write down the step in a foreign language, I try to do a quick translation here, click the submit button to Hawaiian, let's copy that and paste. Even if we write it in a foreign language, the LLM will actually translate it back to English, so it's clear for everyone else. And there's a lot of functionality and features around using LLM in a very seamless way. It's not like a different prompt or anything. It just seamlessly corrects what you're doing, keeping your tests clean and tidy and easy to maintain, and also keeping the testers productive. Okay, so moving ahead, beyond just authoring user interactions, we also, as part of our tests, want to place assertions. So one way to do it is to add visual assertions. As we said, we have support for visual testing, the best visual testing in the market, using powered by Visual AI. I can easily click a button and add a visual checkpoint that would completely cover and verify the state of the page. But I can also add traditional textual assertions. So I can add a verification that verifies that the name is required label is visible. Or I can verify after typing my name, I can verify that the text in the name field starts with Adam, which it does. So the assertion would succeed. If, on the other hand, I would assert that the name field is currently lowercase, this is wrong because Adam Carmi is not lowercase. You'll see that the assertion fails. And if I say that it should be capitalized, which it is, the assertion would succeed. Another important capability is to parameterize the test. So instead of using fixed values like Adam Carmi's name, I can just replace it with a name parameter in curly brackets. That is sufficient to create a parameter for the test that is called name. Similarly, I can do the same for the email. I'll just get rid of the current step here. Let's move it away so it won't execute immediately. And yeah, I can replace my email with an email parameter. Now that I've created these parameters, I, of course, need to provide them with some arguments, some concrete values they would run with, and I do it through the run settings dialog. Here I have the two parameters that I've just added. I can set Moshe as the name, and I can set Moshe's email as his email. I can apply it. And now if I rerun the test, let's take away the breakpoint. If I rerun the test, you can see that Moshe uses the name and the email, Moshe's email is applied. So parameterizing tests is super helpful. It allows us to reuse the test with different arguments, both inputs and expected outputs. And it also allows us to attach a test to a data set, which defines, it's a columnar data file that defines which column names represent parameter names, and each row provides values to these parameters, and I can run a parameterized test against a data set, and it will execute multiple times for each row in the data set, and this allows us to perform data-driven testing. Another important capability is the ability to grab information from the application under test as the test is running, store it in variables, and then use those values in subsequent test steps. So for example, after I submit a contact request, I get this nice message that indicates a request ID that I can use to track my request. So it's very simple for me to grab it and store it in a variable. So for example, there are many ways to do it. For example, I can say, store the value to the right of your request as request ID. And as we do it, see, oh, I have a typo. It cannot find your request. Let's fix it. Okay. And we can see now that we have a new variable, request ID, that holds that request ID. And now I can use this value, for example, to assert. I can say verify that request ID is a number. Okay. Another important ability is the ability for a test to call another test or to run another test in order to reuse the test steps that it has. For those of you who are not familiar with reusing test steps, it has a lot of advantages. So first of all, it allows me to write a much smaller tests that are easier to understand because I don't have to repeat long sequences of steps that are already defined elsewhere. But a very big advantage, and another advantage is that if the flow, the application changes in a way that I need to update my tests and I'm reusing test steps everywhere, I will only need to change and update my single test that is going through that workflow and reuse everywhere else rather than having to go and fix and repair a lot of many tests that repeat the same steps again and again. So it really helps you reduce maintenance overhead and to succeed with scaling your tests. So this is our first test, so we don't have another test to call yet, but we can easily extract one out of steps that we see in this test that we feel that can be reused. We'll pick typing the name and verifying that it's capitalized and then typing the email and extract it into another test and call it. We'll just create another flow. Let's call it enter name and email and click create. And then this other test would get created and we can see that the 3 steps that we have included in it are now gone and just replaced with running that new test that we've created. Fear not, those steps are still here. I can still interact with them. I can place breakpoints. I can run the test and I will see them executing. I can edit them just like I can edit any other test steps as we've seen before. However, they are now part of another test that I can reuse across all of my test suite. The next thing I want to show you is how you can incorporate initiate API HTTP request as part of your end-to-end flow. So allowing the ability to basically, let me just let the test continue for now while I'm explaining. The ability to incorporate HTTP request and do API testing as part of your end-to-end flows is very useful for various reasons. You can use API calls to perform authentication, or you can use it to quickly set up the initial state of your test before running it, or you can use it to clean up directly, clean up the test data in the end of your test directly through the backend. But a very important use for it is to be able to validate the state of your backend as you go through some UI interactions, especially in cases where you don't have any way to do it through the UI. Okay, so for example, with our demo application, after we submit the contact request and get the request ID, there is no way for us to guarantee or check that actually the correct details were stored in the database on the backend. Okay, there is no UI for me to do it. However, what I can do is do an HTTP request to the API of the backend and provide this request ID and an access key, a secret access key that authenticates me. And then I will get from the backend a JSON response that will include the data that is stored there. And this way I can verify and assert on it. So here is this API call. You can see it over here. It's a GET request to an endpoint. It takes an ID, the request ID that I have stored as a variable, and I need to provide a header, which is secret. So I specify that it is a secret. Again, everything in plain English. I can just copy this statement, add it at the end, and it immediately runs. I can look at the step details. I have access to the request details. I have access to the response of the request. I can see that the request went through. I can see that it returned 200 code, which means that it succeeded. You can also note that the secret header is now masked. In fact, it will never appear at all in any test results or in the test description or anywhere, and there is no API to retrieve it. It is safely secured within the platform and only used to run this step from now on, all because it is designated as a secret. And Autonomous can also detect secret by itself by looking at the instructions that you provide. Like if you say it's a PIN code or a password, it will automatically become a secret and will be kept secured. Given the API call, I can access response cookies, the response headers, and the response body. And I can copy all this data. I can access it through the test, and I can also assert on it. I can assert on individual properties, and I can even create an assertion for the entire JSON response body. Now I'll just create that assertion on the response. I will paste it here. You can see that it is a very big assertion because it asserts on a lot of properties. As soon as I enter it, our LLM will actually split it into multiple smaller assertions, so the test will remain readable. And you can say that it is verifying that the email is the expected email, that the name is the expected name. You can see that the contact reason is demo request, and a bunch of other assertions that are less interesting, so we'll delete them. What you can also notice is that our LLM was smart enough to identify that we already have an email and a name parameters defined, so it created and replaced and adjusted the assertion not to include the fixed value that was returned from the HTTP response, but actually use the variables instead. So pretty sophisticated and pretty cool in my mind. So we saw an overview of how we author a custom flow, and I think that you can see that just about anything that a developer can do in code, whether it is in terms of coverage or in terms of the tools and techniques that he has to basically build a test correctly in a way that would scale, you can do here in Autonomous. So all we need to do next is just save this test and run it and look at the test results. So far, we just run it interactively. So we'll head back to our run settings. And besides the arguments that we'll provide, we can also determine the devices and browsers that we'll use to test the application on. Right now, there are 3 of them, and we can add as many as we want. We can create custom ones. Let's just choose all the ones that are currently defined. There are about 10 of them right now. We'll apply it, and we'll click Create and Run. Of course, I didn't provide a test name, so we can provide a name for this test so we can create it. Let's call it Submit a Contact Request and Create and Run again. The test will be saved, and because we asked it to run, we'll move back to the results page. So the results page show us all our test runs. The newer test will appear at the top. This is the first test run, so it's the only one. We can see the status of the test. We can see the name of the test or the plan. I can also run a test plan. It will appear here. The number of tests that are running, the devices and browsers. Oops, let me go back. The devices and browsers that we are running on, and when the test started, and also the progress of our visual assertions. The test has completed, or almost completed, and we can also filter the results here based on the time range, on the status of the tests, on the user that triggered the test. So for example, if you are now debugging some test and you just want to see your test, you can just choose yourself as the runner. You can see you can ask to see just the latest test run per test, or just search for tests in free search. So let's drill down and see what we get as part of the test results. First of all, we can see in the summary view some metadata on the test, such as when it started and how long it took. You can see just 29 seconds for coverage on 10 environments is pretty fast, or very fast, if I might brag. We can see the parameters in use and also the arguments that they got, and a lot of other interesting information. We have a breakdown of the test results per device and browser that the test ran on. There's also a tab to see a summary of issues and changes and visual differences that were encountered. There are none right now. The test screens shows us all the visual checkpoints that were taken. There are 10 of them because we had one checkpoint across 10 different devices and browsers. We can see thumbnail views of those screenshots, the same contact us form on different form factors from mobile to desktop. And we can also see a step-by-step breakdown of each test step. Each one of them, like we had in the interactive browser, shows us a capture of the outcome of the step, how the UI looked like before the step was executed, the element that we interacted with. And we can also see for the API call, we can see that the secret is masked. We can have access to the response details as well as the request details. And besides all of that, we can also have access to console logs, and we can also play a video recording of the remote execution on our execution cloud. So we have everything we need to understand what occurred in a test, what was covered, what was done, and in case of an error, we have a lot of information to debug and understand what happened. So at this point, I'd like to circle back and talk a little bit more about visual assertions. Let's go back and edit our test. Let's run the first command. And if you recall, after heading to the Contact Us form and clicking the Submit button, we started by adding a visual checkpoint. So I'd like to explain how a visual checkpoint works for those of you who are not familiar with it. So when a visual check executes, what happens is that Autonomous is grabbing a full-page screenshot of the application under test on each and every one of the devices and browsers that we defined in the run settings. It then takes those screenshots and compares them with baseline images that define how the application is expected to look like at this point of the test in each and every one of these devices and browsers. If there are no differences in between any of these images, the assertion passes. If there are differences, the assertion would actually be marked as unresolved, and so would the test. It is marked as unresolved because the fact that there is a change doesn't mean that the test failed. Maybe it is an expected change and the test actually passed, and we just need to update the baselines. It also could be an unexpected change, which is a bug, but we need to give that feedback to the system. So it will be unresolved. Our test results in the Screens tab will show us exactly what changed, and we can provide the indication of whether we accept or reject that change. So to see this in action, what we will do is that we will actually run a JavaScript snippet that will cause the first error message that indicates that the name is required to become white. Okay, this will cause it to be less apparent or almost completely disappear. And this is a change that we would like to see how it is caught by our visual assertion. So we have the snippet over here. Okay, let's copy it. And we can paste it right after clicking the Submit button. Just so you see what it does, it executes JavaScript snippet that finds this element by its class name, and it then sets the foreground color to white. Okay, we can run it, and you can see that the message is gone. Okay, the first error message has disappeared. So that's it. Let's rerun our test and see what we get. While the test is running, I'd like to spend some time correcting a very common misconception. A lot of people think that visual testing is all about just finding style issues in your application. But in fact, it is an extremely powerful tool for functional testing as well, much more powerful than textual assertions. So if you think of it, if you had a baseline for a calculator that would capture the result of 1 + 1 = 2, and you would have a functional bug where the result of the addition would come out as a 3, a visual assertion will catch that because a 3 doesn't look like a 2 as it appears in the baseline. However, it's a functional bug, and there is, of course, it has nothing to do with style or design or UX or anything like that. So a functional visual assertion also covers everything about the appearance of your application, but also a lot about the functionality of your application. Okay, so the test has ended, and we can see our 10 screens that are now no longer green. They are orange, indicating that they're unresolved. And if we click on any of them, we can see that each of these checkpoints has the baseline image on the left-hand side, the checkpoint image on the right-hand side, and the difference is highlighted in pink. We can also mark it so we don't lose small differences and easily zoom. We can see again the highlighting of the difference. The name is required appears on the baseline, and it disappeared on the checkpoint image. Now, the same checkpoint also applies to other form factors as per the devices and browsers that I selected. Okay, mobile, desktop, etc. Now, visual assertions have many advantages over the textual assertions. First of all, you can see that a single step, a single assertion actually covered an entire page and is equivalent to having to write 100, if not thousands of equivalent textual assertions that, of course, no one has time to write and maintain. Now, because you get so much coverage, there is no longer a need to add all those textual assertions. And from the statistics that we see with our customers, this brings down the size of the test by 80%. Think about it, it's a staggering number. 80% less test steps means 80% less test steps to author when you're writing a new test, but more importantly, 80% less test steps to maintain for the entire lifetime of the test. Okay, so it's a huge, huge, huge productivity gain. The last advantage is that when the UI changes, as you know, the UI changes a lot, instead of going back to tests and updating and replacing the assertions there, all I need to do is decide whether I want to accept or reject the changes. If the changes that I see here, if it's an expected change, I intentionally wanted to remove this error message as part of the sprint, all I need to do is click an accept button. And this will cause the checkpoint image to become the baseline image for subsequent test runs. If, on the other hand, this is an unexpected change, or in other words, a bug, I just need to reject it. The baseline would remain the same, and the test would be marked as failed. Let me go back for a minute and look at the test flow and show you something interesting. You can see here that our visual check now appears unresolved, which means that there is an issue or something we need to look at. But the textual assertion that needs to verify that the name is required label is visible is actually passing. And the reason that it is passing is because the element is still there and it is still visible. It is just white over a bright background, which is why it is invisible to the end user. So the functionality of showing that an error message is broken, but still our textual assertion is passing. And there could be an infinite number of ways for this functionality to be broken and for this assertion to still succeed. Just to contrast between how weak a textual assertion is compared to a visual assertion. So with Autonomous, you can go both ways and choose the methods that you need, but having solid visual checkpoints is an invaluable tool to succeeding with automation at scale. The last thing I want to show you is automated maintenance in action. What does that mean? We know that accepting and rejecting is a click of a button. It's very easy to do. But what happens if a change now appears 100 times across my test suite? Because it's very central and it occurs on all devices and browsers and in different states of the application. Even if accepting and rejecting is very easy, looking at 100 occurrences of the same difference and accepting or rejecting again and again can be a bit overwhelming. The good news is that with Autonomous, you don't need to do it. We know that the error message missing is a bug, so we need to reject it. It doesn't matter on which screen we reject it. As soon as I provide this feedback, Autonomous automatically start analyzing all the other test results that are available, that were in that run, and it automatically applies my decision everywhere where the same difference occurs. So basically, instead of looking at 10 places and rejecting, I just had to reject once. And there are plenty of AI-based, extremely advanced features in the product that really allow you to scale your coverage, scale your test without increasing the amount of maintenance that you need to do. This technology is also available in our ICE product and can be used to augment any type of test written in code, whether it's Playwright, Cypress, Selenium, Appium, XUI, Espresso, more than 40 test environments that are included. And what I can tell you from the statistics in ICE is that for every maintenance operation that a tester, that a user is doing in our dashboard, is that there are 3 that are done by AI through automated maintenance. So for every action that you do, 3 are taken automatically. Just imagine that you are quadrupling the size of your team or the magnitude of your team using automated maintenance. Okay, so I think that I've shown you everything that I plan to show you with regards to custom flows. And next, I want to talk about full website tests. Now that we understand custom flows, it's very easy to understand how full website tests work. As I mentioned at the beginning of the webinar, all I need to do if I'm testing a website or a content management system type of application is provide the URL of that website. Let's go ahead back to our demo and go to the start page and provide that URL. Once I provided it, I already have 3 devices and browsers selected, and I click next. What's happening now is that a full website test is starting. And what it is doing is that Autonomous is visiting that website now, crawling it, finding all the pages that are there. Any HTTP error that it encounters will be reported in the test. So if a page crashes or is not found or is inaccessible or is timing out or slow to load, anything whatsoever that happens, Autonomous will report it. If, on the other hand, the page does load, Autonomous will automatically render it on any device and browser that you choose and specified, and it will perform a visual checkpoint of it, which gives you a complete coverage for that page. And this means that any change that your end user will see with regards to your website, you will know about it, whether it's new content that was pushed, a new feature, whether it's a bug that you introduced. And even if you didn't change anything in your website and it's just a new browser version that updated that caused some incompatibilities with your website, you will know about it. So Autonomous finished running the test. It detected 11 screens across three devices and browsers, three environments, so 33 in total. It did found an issue. The issue is that the about page is not found, 404 error. We can copy it to the clipboard, try to find it in production, and we see that indeed it is not found, so we have found a bug. And right now, this first run just established baselines. We can now run the test. We can schedule it to run frequently. We can trigger a test run from the API, from an external CI. And we can, of course, edit the devices and browsers that we run on. In general, we didn't need to do anything but provide the URL for the website. If in the future new pages will be added, the coverage will be expanded automatically. If all of a sudden a page would be removed from the website, this will come out as an issue on a test. We don't need to do anything to maintain this test suite. We just need to sit back and wait for test results and then decide whether to accept or reject differences. So super easy, a completely autonomous solution. And with this, I've concluded my demo. And I really hope that you are impressed and you are now just as excited as I am with Autonomous. If you are and you would like to see a demo, meet with our team and see a demo of Autonomous on your application or start a free trial, feel free to scan the barcode or just visit the link that you see here. And I'll be happy to answer any questions that you have at this point.
Thank you so much, Adam. So we have a lot of questions that came through, which is great. It means everyone was engaged, and I love that. And I want to thank everyone so much for asking all of these questions. How does a no-code testing tool handle dynamic elements, flaky tests, and frequent UI changes?
Yeah, so as you saw, basically you can describe user interaction just as you can in code. You can refer to dynamic elements by saying things like the element to the right or below some anchor that is not dynamic. When it comes to visual assertions, it's very easy to handle dynamic data. It's outside the scope of this discussion, but we have match levels that automatically ignore like common dynamic data like dates and times and prices and credit card numbers and stuff like that. And you can customize the patterns. You can perform comparisons by the layout of the page. If things are moving around, you can ignore movements and displacements. So just everything that you can imagine solving with code, you can do with the custom flow. And in terms of visual validations, the solution is extremely mature, and it can handle just about any scenario, dynamic scenario that you can imagine.
All right, next question. How does Autonomous handle versioning of tests? For example, if you want to run tests regularly against a stage or production environment, while also updating tests for large feature changes in, say, a dev or QA environment that aren't yet released?
Yes, so this is right now the way that you would need to handle it is you will need to create separate applications for those separate versions of your tests. You can easily copy tests from one application to the other, so it's a bit it's less cumbersome than it would sound. You can just, once you have an update, you can just select all tests and copy them over to another application, so you don't need to double maintain those two tests. When it comes to just changing the start URL, that's very easy. If the tests are the same and you're just testing against different deployments, then you can just parameterize the start URL and then provide a value to that parameter, just like you saw with the name and email field. And so you can just run the test across those different deployments.
Mm-hmm. Perfect.
And it's of course, it's not that we are stopping here. Autonomous is a tool that is being developed at very high velocity, and the ability to version tests and also retain historical version of tests and go back to historical versions and blame the infamous blame feature. All of that will be supported in one of the new releases of Autonomous.
Exactly. And all right, I'll keep moving through questions here. Which AI models does the autonomous product rely upon?
So first of all, the language model that we are using, that you've seen me typing, is our own language model, which is extremely important and an important advantage of our tool. It means, as you saw, it is extremely fast. It will also not hallucinate, and you don't need to worry about a case where the test is passing and now there is a bug, and all of a sudden the AI becomes creative and finds a workaround for the scenario, and you don't know that the bug is there. Everything is deterministic at time of execution, and it also gives us full control on the runtime and the language model itself. So if you encounter a bug, we won't ever tell you, no, that's Microsoft's issue, it's not 100% accurate, we can control it. We actually have full control on everything, and we can enhance, fix, debug, and do whatever it is we need to do. Some of the LLM stuff that you saw, like translating between languages or taking very weird and creative sentence in the English language and simplifying it, we do utilize an off-the-shelf LLM. We use various models from the popular providers. It is important for me to highlight that nothing in this product learns from your test data. Absolutely nothing. All the models that we use are only used in production just as input-output. They don't learn from the data, and we never use any of our customers' data to train our models. So there is zero chance that any of your proprietary data will find its way, not back to you, and definitely not to any other customer.
Yes, that's a great point to make. And then our next question here, can common steps like login be shared by many tests so that later when the step changes, it can be changed in one place instead of redefining the step for each test using it?
Yeah, this is exactly what I've shown when I shown the ability of a test to call another test. Any test can call another test, except if you create an infinite recursion. And this way you can reuse tests, just like developers can define functions and call functions to achieve the same goal. By default, when you run a test, the start URL navigation in that test is skipped, as well as all the assertions, but you have full control over that. You can just specify whether in plain English or through the UI that you want to run a test, but still navigate or still perform visual assertions or textual assertions or both of them, etc. So you can reuse, and this is how you do it.
Exactly. All right, this is going to be our last question because we are a couple of minutes over time now. The last question, can we run these on a schedule?
Yes. One part that I didn't have time to show is the test plan. Autonomous has a test plan feature that allows you to group together tests that should be run together. In the test plan, you specify those tests. You can also specify the schedule by which they would run. You can specify the devices and browsers that will be used to check the application on, and also provide the test data that will be used to drive these tests. Once you have a plan, the plan will execute on schedule. You can execute the plan manually from the dashboard, and you can also trigger a plan run through an API. So if you want to control it from your external CI, you can trigger it through an API and also receive all the test results of the plan programmatically through that API.
Exactly. All right. Adam, thank you so much for sharing your expertise and time today. And thank you everyone who has joined us. If we didn't get your question, we did capture them. So we will be sharing them with our product specialist for follow-up. And there is also a link where you can set up a quick call to discuss any specific use cases you have on the resources tab. And as mentioned at the beginning, be looking for an email tomorrow with a link to the on-demand recording and the session materials. We'll also include links from all of the resources featured today. And that being said, we hope that you've seen today how our end-to-end testing platform lets your team of all skill levels create, run, and maintain powerful tests that validate more in less time. And if you're not yet an Applitools customer, you can see firsthand the power of leveraging AI in your pipelines by signing up for a free trial. But for those of you that are currently Applitools customers, who we love so much, please do reach out to your account team to learn more about how your team can take advantage of some of these strategies and use cases that Adam's outlined today. Again, thank you for joining us, and we hope to see you all again soon. Take care.
Thank you, everyone. Bye-bye.